Okay, so we use the REP charts to determine how many atoms of each element are on both sides to determine if the law of conservation is true. In another way, we want to know if these equations are balanced or not. Okay, so R is for reactants, E is for elements, and P is for products. So the first thing you do is identify the elements in this chemical equation. We have iron, which is Fe. We have sulfur, and we have oxygen. Okay? Then we're going to identify the number of atoms on the reactant side. So I have 4 atoms of iron. This coefficient tells me I have 4 atoms of iron. This coefficient also tells me that there are 4 atoms of sulfur. Now, when we have a coefficient, we distribute to our subscript. Iron and sulfur don't have a subscript, so that means that there's 1 atom. So 4 times 1 is 4, 4 times 1 is 4. But with oxygen, we have a coefficient of 7 and a subscript of 2. So you distribute and multiply. So that means I have 14 atoms of oxygen. Okay? Then we do the same thing on our product side. I'm going to distribute my coefficient and multiply it to my subscripts. Okay, so 2 times 2 tells me I have 4 atoms of iron. Okay, the next is sulfur. Distribute my coefficient. I have 4 atoms of sulfur. Now, notice there's oxygen in 2 places, so this is what I like to do. I distribute my coefficient to oxygen, so 2 times 3 gives me 6. But I also have oxygen over here, so 4, distribute your coefficient, times 2 gives me 8. So 6 plus 8 equals 14. So is this equation balanced? Yes, this equation is balanced. Okay, I'm going to do another example. Okay, so first step is record the elements that are involved in this chemical equation. I have phosphorus, which is a capital P. I have chlorine, which is Cl. Hydrogen, and I have oxygen. Those are all the capital letters that I have. Okay, remember that this is Cl. Okay, so I'm going to count the atoms on my reactant side. I have no coefficient and no subscript for P, so that means I have 1 atom. My subscript for chlorine is 5, telling me there are 5 atoms. Okay, for the second formula, I need to distribute my coefficient to my subscripts. Oxygen does not have 1, so that means it is 1. So hydrogen is 4 times 2, so I have 8 atoms of hydrogen. 4 times 1, I have 4 atoms of oxygen. Now I'm going to count the atoms on my product side. I'm going to count the atoms of the new substances. So hydrogen has 3, phosphorus has 1, and then oxygen has 5. I have a coefficient here, and I need to distribute it to my subscripts. Neither of these elements have a subscript, so you're multiplying by 1. Hydrogen has 6. Chlorine has 6. That equals 9. Is this equation balanced? I have one atom of phosphorus on my reactant side and 1 atom on my product side. I have 5 atoms of chlorine on my reactant side and 6 atoms of chlorine on my product side. I have 8 atoms of hydrogen on the reactant side, but I have 9 on the product side, and I have 4 atoms of oxygen on the reactant side, but I have 5 atoms of oxygen on the product side. No, this equation is not balanced, so I'm going to put a U. This equation is incorrect, and it is not possible. Because mass cannot be created or destroyed, whoever wrote this chemical equation made a mistake with their coefficients, okay? Because you need to have the same number of atoms on the reactant side and the product side, okay? I think I have time for one more example, and we're going to practice the rest of these tomorrow, okay? Okay, so first thing I do is calculate what elements I'm working with. I have As, which is arsenic. I have Na, which is sodium. Oxygen. And I have hydrogen. Okay. The number of atoms on my reactant side for arsenic is 2. This coefficient tells me there are 2 atoms. For sodium, there's no subscript, but there's a coefficient. I distribute my coefficient to each element. So I have 6 atoms of sodium, 6 atoms of oxygen, and I have 6 atoms of hydrogen. Okay, now I'm going to do the product side. I need to distribute my coefficient and multiply it to my subscripts. So for sodium, I have 6 atoms. For arsenic, I have 2. Oxygen, I have 2. I'm going to distribute my coefficient and multiply it by my subscript. For hydrogen, I have 4. Is this equation balanced? Some common questions that I usually have for this is, why doesn't the coefficient apply to everything on this side? The plus sign, guys, separates these chemical formulas. So this is one part plus this part. They're separate, okay? And the goal is to identify whether or not they are balanced by calculating the number of atoms for each element on both your reactant side and your product side. Okay, and we know that this is unbalanced because I do not have an equal number of oxygen atoms and hydrogen atoms on both sides.